problem, we should find maximum force exerted on the floor, on the surface by the spring. And this force is very simple. It's obvious that spring force. So contact force between floor, surface, and the spring is a spring force, basically K spring constant times compression. Here I'm not paying attention to the direction, I'm just paying attention to the magnitude, to the numerical value. So force between spring and the floor equal to spring force, which is spring constant times compression in this case. So as you see here, this force can be maximum only in one case, if we have a maximum compression. So maximum compression happens when this object stops its motion or when its velocity becomes zero. So let's say it's somewhere here. It's somewhere here. So at the beginning, when you release this object, it will start accelerating downward. Velocity increases till it hits the spring. Here velocity decreases because we have a spring force upward, and the velocity will decrease, and it will be equal to zero after some point. And at this point, force will be maximum. So basically this X is this compression. Now we need to find maximum compression. Maximum compression will be when velocity of the object becomes again zero. So this part is totally comes from conservation of energy. So we need to now write conservation of energy formula equation. So conservation of energy. Let me write conservation of energy. Here we have a potential energy because height is changing. So let me write potential energy according to the surface, according to the table. So what is the conservation of energy? Conservation of energy means total energy at the beginning, initial, should be equal to total energy, in this case of course mechanical energy, at final position. So at the beginning we have only potential energy of this object, which is mgh. That's all. There is no potential energy of the spring because it's not compressed, it's not extended. There is no any velocity, so there is no any kinetic energy at the beginning. So at the end I mean when object's velocity again becomes zero. So this position. At this position, this object again has its potential energy because we have a height here. We have a height between surface and object. And if you pay attention to this figure, this height equal to L minus X. So object has a potential energy mg L minus X. Also, the spring is compressed, so we have a spring potential energy, which is 1 over 2 kx square. So we have this kind of energy equation. In this equation we have only one unknown x, compression, and we can easily find x and come to the original equation, and we can determine the maximum force. So let's continue. Further is totally mass. So we should be careful. So as you see from this equation, we have two roots, two answers basically, because we have a quadratic equation. So here we have 1. 1 is A. This part is B. And this part is equal to C. So x equal to minus B plus minus B square minus 4AC divided by 2A. So negative it will be positive 2mg over k plus and minus b square 4m square g square k square minus 4a is 1, c is 2mg k l minus h over 2a. A is 1. So let me cancel 2 here. We can take 4 outside and square it will be 2, so we can lose it, we can cancel it. And be careful here, L is smaller than H. So pay attention to the figure. H is greater than L. So L minus H is negative number. So let me replace their places. So H over H minus L with negative. So negative times negative, it will be positive. So let me rewrite this equation. Mg over k plus minus. Here we have a m square g square k square plus 2mgk h minus l. So this part is positive number totally. So here we will choose plus sign because under this square root we will get value more than mg over k. It's obvious. Here we have a plus. This part is positive number. So if you choose minus sign, at the end we will get negative number, negative compression, which is impossible. There is no physical meaning. So that's why we choose positive plus sign. So our final answer, maximum compression, equal to mg over k plus square root m square g square over k square plus 2mg k h minus l. And the maximum force equal to k times x. From here answer will be mg plus m square g square plus 2mg k h minus l. And this will be our final answer.